Okay, we're going to repair a broken link cable port on a TI-92, and we can see here this is broken completely off. It still may work, although I didn't have much luck with the GraphLink software. So we're going to replace that. And I've already fixed some of the other issues with this, but this is a standard TI-92. This would be a similar process for the TI-92 Plus. They use the same connector. So I'm going to go ahead and take the back cover off and put that aside. And we can see, and that connector right there is broken. Big chunk of it missing. And I've already cleaned these contacts, which is a common problem with these if you get one used. This one's in great condition though. I don't believe I had to clean this all that much, but I did get it working, and then I tried to do program backups and things like that, and was unable to make a connection even though it looked like the conductors are still in there. It just needs to be replaced. So first step here would be to remove the series of screws on the back, and these are standard Phillips. If this were the TI-92 Plus, these would be like a star screwdriver would be required there. So we'll just remove all of these, put them aside. There's quite a few screws in here, which is good in some ways because it keeps, especially the ones on the edges, keeps the battery contacts firmly pressed against the PC board there. It keeps this a pretty solid design here. And this one is really tough to get out there. Okay. So we have the 3 on each side toward the edge, a few in the center. Okay. And I think I did that one already. This one down here. And then this one, again, the 92 Plus wouldn't have this removable, but this is for the option ROM pack. Take that off, put that to the side. So this is an early model TI-92 because the ROM is on the PC board. The later models forego this ROM and instead would have the option pack installed. And there's a TI-92 Plus module as well, which I have one of those, which turns this into a TI-92 Plus with a little bit less memory than the real thing. All right, so then that's the last remaining of the screws, and I'm going to remove these in a controlled fashion here, rather than have them fall out all over the place later. Okay, I forgot one over here. Okay, that looks like the last one. And on occasion this will stick a little bit, and I'll show you why. So oftentimes you'll get corrosion, usually, and oddly, I don't know why that is, but on the negative terminals here, and you'll get corrosion here sometimes, which causes these contacts. These don't really corrode, these are easily cleanable. It's like a stainless, flexible steel there. I've never seen these corrode. The corrosion is clean that with some vinegar or anything that's a light acid. Usually, again, the corrosion will be on these pads on the bottom, and it can make its way up to the top as well. And the cleaning method there is a fiberglass pen, some vinegar, and an isopropyl to clean it off. I did not have to clean these at all. So this is a good condition TI-92. Now one thing, a bit of caution here, all the screws are removed. Definitely do not tip this the other way. Don't rotate this way. The PC board can fall out, and so can all the keys. And if that happens, you'll find yourself either looking online for a picture of where all the keys went, or another model as a reference to get all the keys back in there. So my advice would be to take the PC board out, put this somewhere on a flat surface. Oh, there's one of the keys already fell out. It was stuck to the, it's F5, stuck to the rubber keypad there. Put that to the side. Also, in my opinion, avoid putting any pressure on this LCD flex strip here. There's a adhesive, heat activated adhesive right under here. You do not want to put any pressure on that at all. That's a common problem with these if they get dropped. And I'm going to go ahead and take the rubberized keypad off and put that aside. And sometimes, again, you'll have corrosion. If it's a severe case of corrosion all over the keypad, I've had to clean a few of those before. And now we can see the 2.5 millimeter graph link connection here. And this is just an example cable to connect one calculator to another using a 2.5 millimeter to 2.5 millimeter. So the graph link cable for a PC or Mac will have this on one end and a USB on the other. But the idea is that this plugs in here. And although this probably does make an electrical connection here, having this broken off definitely might not be a good operating condition there. Now this shield is just held on by some mild adhesive. It's very easy to get off. So we'll go ahead and do that. I will go ahead and pull this shield up. And we're going to not really remove the whole thing because it's not necessary for this repair. And I'd like to keep as much of the adhesive in place as possible. So we're just going to fold that back just a little bit. And leave that over there so it doesn't get in the way. And this is the flexible PC or flexible LCD ribbon cable here, and the heat activated adhesive pads are here. So you definitely want to avoid touching this area, in my opinion. It's possible to repair that with some heat, but we're not going to touch that. This calculator is otherwise fully functional. So we're going to remove this connection here. So we have one in the back for the tip, and I believe this would be the sleeve and the ring, which would be over here. If I have those backwards, I wouldn't be surprised. But there's 3 conductors, and if you look here, there's a 3-conductor cable jack. So when this is put into the jack, this makes contact here, the middle makes contact over here, and then this contact here is for the sleeve. Now, there is, for some reason, a piece of tape here, and I'm not sure if that's to prevent, now this shield doesn't get in the way. Maybe the battery contact may come close to this, so we're going to save that. That seems to be an afterthought here that this was put on. So I'm just going to take that off and save it because that's probably there for a reason. So we'll go ahead and save it. Put that here. And now you can see the pad there. Okay, let's warm up the soldering iron. And let's get started. I'm going to put on my magnifying glasses here. These things are fantastic for seeing. And we'll get started. So the first thing I'm going to do is get some solder wick here and remove the solder that's currently on those connectors. This usually works fairly well. And the soldering iron is warmed up. Get this out of the way. So the tip on the soldering iron that usually works better for removing solder with a wick is a flat tip or wedge tip. Something like this works well, and I usually just heat up, avoiding contact with that plastic housing. And this is not melting very easily, so let's see if we, yep, there we go. So I don't like to get plastic on the tip of the soldering iron all that much. And on occasion you might have to use flux with maybe adding a little bit more solder. It seems counterintuitive, but it can help free it up if the heat's not transferring all that well. I'm just removing a lot of the excess, and then we can easily lift these pads, and it should do the trick. And we can see that solder is being wicked pretty easily. And there's some adhesive there, which is probably getting in the way of heat transfer, but let me get the last bit here. Actually, I'm going to use a little bit of flux on that. That is not cooperating as nicely as I would like. So, because I don't want a lot to clean up later, I'm going to put the flux on the wick and give that a try. And again, I try not to use too much heat because I don't want to melt the housing, even though this part is being disposed of. It just makes a mess on the soldering iron. So, okay, that's enough to get the majority of it off. So what I'm going to do now is I am going to carefully pry up each of these legs. Again, we're disposing of this part, so let's see if this is a little bit of solder left on there. And I don't want to use the heat gun. I think that's a little excessive. This one broke right off. That one broke off. We have to be careful not to break the pads. Okay. So we'll remove the leftover pads off of there. The conductors, the little pins. And there is going to be a little bit of flux on there, so we'll clean that off with IPA. Again, I'm trying not to touch this flexible cable all that much for the LCD. And it looks like we have a good surface to put the replacement part on. So there are only 3 conductors here. So we have, again, the sleeve, the ring, and the tip, and there's no damage to the pads. So this is a good thing. No corrosion in that area. And this is the old connector here. And you can see that, although I broke this pin off here, that on the PC board, this was the sleeve, the ring, and the tip. Now on this part, the tip pin comes out of the back, and that's where the pad is here. And on the replacement part, which I'll link in the description, is again 2.5 millimeter jack. I'm working on another project, so I just happen to have these a few extras here, and these are very similar, except again for the other project I wanted to detect when a cable is inserted. So for example, this would go here, and there's a little switch in the back here, so there's an extra leg for the switch to detect that the cable's been inserted. But for this particular application, it's not necessary, so I can reuse the same style jack. And if you notice, the good thing here is that the sleeve, the ring, and the tip, at least the sleeve and the ring, are in the same positions as far as the pins. However, the tip is on the side, and it's on the left side on this. And the way you could detect that to verify it is with a DVM. We'll put this in continuity mode here. Let's move this out of the way. Set this up here. And we'll put this in continuity. And what I did is I plugged in a graph link cable onto one of the ends. I put the connector on there, the replacement, and just verified the pinouts the same. So for example, this pin over here, the sleeve, should be sleeve here, and it is. The ring is the ring there. And then I tested this one for the tip, the one on the left. The one on the right is the switch. Normally it is open. So it is not connected to the tip, and then when there's a cable inserted, they are not connected. Again, we're not using that for this application, and when you unplug the cable, those two are switched. So one of those legs we're not going to use, and it's very important, the left pin is the one that's connected to the tip when the cable's inserted. So the pinout is the same, which is good. And if we look at an example of the alignment on that, just get a spare unit. This one is work in progress. This one has some severe problems, but that is a good working connector here. And it comes out, there's the barrel part of this, and then there is the solid housing that's more square shaped, and that is coming out about 1 millimeter off of the board, so about 1 millimeter up from the PC board. So we can't go too far up, and it's right at the surface of this plastic face here, and it can't be too far recessed because then the cable won't make a good connection potentially. So it has to be level with the plastic, so it's about 1 millimeter up. And luckily this part is almost exactly the same dimensionally, so the barrel part versus the square plastic housing is almost exactly the same size. So what I've done here is, if we line this up, and I'm not going to place it exactly, but if we line that up, we can see that this tab is perfectly aligned with the pad on the PC board, and this tab here is also perfectly aligned. However, the one in the back is not, and the one on the left, to be specific, is not exactly, there's no pad on the side. However, this pad is large enough where if we scrape away some of the solder mask, there's a little bit of surface area here that does make contact with the pad. And so rather than using some wire, bodge wire, or anything like that, I want to keep this against the surface of the PC board and not be, if I put a piece of wire under it, it may be tilted up a little bit in the back, and it won't be perfectly aligned. So I'm going to scrape away some of the solder mask here, and then that will make contact with this pad on the left. And the other thing to notice is that these have some placement pins. They're plastic, and these pins, when you design your PC board, I'm working on another project that uses these, there are holes drilled into the PC board where these align for placement, for the automated placement. And of course, if you're manually soldering these, this helps place it and align it. Now, the holes in this PC board, there's one, and it does not align with either one of these pins, with these tabs that are molded into the plastic, and that's okay. So what we're going to do is, I'm going to take an X-Acto knife and I'm going to just break off these two tabs, because what's going to happen is that's going to cause us to not sit on the PC board completely flat. and so the pins won't make good contact. So I'm going to very carefully shear these off. There's one, there's two, and they're gone. And now that's going to sit perfectly flat on the PC board. And the alignment, again, centered with the existing pads that are on the left. So the sleeve and the ring, just horizontally aligned just in the middle, and then 1 millimeter forward on the plastic housing, not the tip here, but the square part here. And so that looks about right. And I'll see if I can zoom in on the edit here, but this is the pad that we're going to sand off the solder mask, and that will make contact here, so that we have all three connections. And I'm not sure of a better method here to do this other than to use a fiberglass pen and sand off the surface. I'm going to move that connector out of the way. Sand off the surface of the solder mask there in that one area. So we're going to sand off, you can see the square footprint marking here. We're going to just scrape off a little bit of that on the edge, and that's where we're going to make our connection when we solder the new one on. So I'm usually pretty careful doing this, not too much pressure, but it's fairly straightforward to get the solder mask off. And you don't want to do it too much, you just need to expose the copper underneath. I don't know how thick or thin these traces really are, and I definitely don't want to damage the trace or the pad. I don't want to lift it. I don't know, again, I don't want to go into the adhesive on that layer. I don't want to thin the pad at all, but I need enough to make a good solder connection there. And one thing to note is these jacks, these types of connectors, may have a little bit of force on them. You know, as people are plugging in the jack, unplugging, etc., there's some force on that. So these pads have to stay fairly well adhesive to the board. We can't have them lift or be damaged. And the more pad contact you can get, the more mechanically sound that connection's going to be. So that's kind of important. And I'm going to do this off the camera. I'm going to just dump that fiberglass onto the floor, vacuum that up later. Okay. So we do have quite a bit of surface area there now on that pad. I'm going to clean that with some IPA real quick, just to get any of those fibers off of there. Clean the pad, and that'll make good contact for the soldering. So the first two pads are fine, no damage there, and this is the pad that we're going to have the tip of this new connector is going to make contact with that. So what I'm going to do is I'm going to tack on only one. I'm going to basically put this in place and just tack one of the legs down with some solder. Then I'm going to put it back in the case, at least just the front part of the case, just to see where it lines up. If I have to adjust it, it's far easier just to hit it with the iron real quick and just tap it and move it forward, back, left or right. I don't want to tack all three of those down. So what I'm going to do is visually align it as best I can. And the easiest leg to tack would be, again, in just the way I have the board oriented right now, would be the sleeve, not the sleeve, the ring, which is the middle connection. And so, again, it has to be straight, flat, perfectly aligned. It's not rocket science, but it does matter somewhat. There's some tolerance in the case, and there's some tolerance in the gaps that are in the case. So, again, same soldering iron tip here, just the wedge. And this is going to be a little tricky. It's going to move a little bit, but I'm going to do my best just to tack that down. Again, make sure it stays flat. And that looks about right. So I just tacked one leg slightly. And then what I'm going to do is put this back in the case, the front case. So just align this. This is nice because this has some guides here for placement of the rubberized keypad. I usually try not to touch the carbon tracks there too much. It's just easier not to have to clean that. And I'll place this into the case. Again, watch out for the keys. They can come out very easily. I'm holding the board so that doesn't happen. And as I look at that, it's probably a lot of reflection, but we can see that the placement of that is pretty much spot on. It's coming right to the surface. And I could also put the back on just to verify the clearance here, but I've already done this on a few models today already, so that is definitely a good placement. We need this. So now what's left would be to tack the other two connections. So I'm going to tack the easy ones first so it doesn't move all that much, and then do the difficult one, which is the one in the back where we had to sand off some solder mask in there. So let's go ahead and make sure that this is pushed down against the surface of the PC board. And just a little bit of solder, a little bit of heat, not too much. We don't want to melt that new connector. And then the back is the tricky part here. And again, what we're going to do is just, that leg is just exposed enough on the pad here where we can get a little solder underneath there and still have some mechanical stability there. So just hit it with some solder. Again, avoiding extra heat. Less is more. Could always hit it again. Okay, so that made a good connection there. And what we can do to test it if we wanted to, we could plug this in, and the continuity meter here, go ahead and test with the pads on the PC board just to make sure we got a solid connection. So one end of the cable, we'll do the sleeve first, and the sleeve is the outer ring, which is here, and that tests okay. The ring, which is the middle conductor, is over here, and that tests okay. The tip, which is the one we're concerned about because of our rigged solder mask sanding, is right there. So all three connectors are good. We don't have any shorts across either of those, and that's good to go. That is a solid connection. So now that that is soldered in place, I didn't really use any flux at all here, so it was a clean enough surface to work with. So that is how we replace the jack. And the old one, I guess there's not much use for this other than maybe to try to find an exact replacement with a pin for the tip coming out of the back, but I don't really think that was 100% necessary. And I'll link in the description, I'll link to the part number on Mauser for these, for their part number, and also the manufacturer part number. So that's a fairly easy repair there. And the shield, again, you know, there's enough adhesive still on here to hold that in place. And this does have several points where even if there was no adhesive, this will stay exactly where it needs to be. So for a replacement, putting this back together, it's the same, just in reverse as taking it apart. And let's see, we have, let's make sure none of the keys are misaligned. And again, good idea if you have a unit that needs some cleaning, you know, clean the 4 pads here or anywhere else where it's spread, and then just make sure these are clean. And these are somewhat still springy because this is what makes a connection mechanically to the pads on the PC board here. These rarely leak. I've never seen a button cell leak, so usually the leakage is going to happen from somebody leaving AA batteries in there and then putting it in storage. Also make sure that this locking mechanism is still in place and doesn't fall out. And I just generally line that up. There are enough screws in here to keep it aligned otherwise. And then I'll usually put in a diagonal lower right, or lower left, upper right, and tack those down first. And go from there. Also, when I ever work with something with plastic, with these plastic screws, if it doesn't seem to be easy to turn these, don't force it, just back them off and try again. You don't want to cross thread that plastic, especially in the four corners, because that's what's really giving you that mechanical pressure for the battery contacts. The other ones, yeah, but again, you don't want to cross thread these too much. And remember, there's no screw here. This is where the compartment cover goes, and it has its own screw. So it's really these four, or these other three here. So the upper right does not get one of these screws. And we'll close these down a little bit. And this one here. This one here. Okay. And I may or may not be publishing some other videos on the repairs that were needed to some of these other units with a lot of corrosion. I've resurrected a couple of 92 pluses that took quite a bit of bodge wires. We had some traces in there that corrosion got at, and the keyboard wasn't working well, and I fixed stripes on an LCD on another model using a little bit of heat from a hot air gun and a plastic spudger, just something to very carefully press the connector down again and kind of reactivate that adhesive. It doesn't always work. Oftentimes it's temporary and it ends up coming back, but sometimes you can get it right. So we're missing one screw. That always happens. We'll take these 200 magnification glasses off and see if I can find where that went. Yep, I forgot one here. So let's tack that one down. Oh, maybe that's not where one goes. Let's see. Okay, and then we have one left here. I have a donor unit for now. I will be borrowing another screw from that one, because that screw is going to pop up when I clean up the bench. So just grab that one for now. This is one that has heavy corrosion. It needs a couple more traces to be fixed there. That one, this one here has, yeah, this is the one that I went to pull. This had such heavy corrosion here on the four posts. I went to pull out, because again, on the ones that have an option ROM installed, or if the ROM is actually not soldered in, it's a module with the header pins here, and you have to remove that module in order to get the back cover off. And I'm always very careful to carefully pry up on both sides at the same time. There's a little bit of space here to do that, and I did, but it took out one of the pins with it, and the pin ended up being stuck in the ROM module itself, and it pulled it right off the PC board here. It corroded and broke because the corrosion had followed a trace. And I ended up, on another model like this, I ended up using a heat gun to take this off, because this isn't necessary on this one. I'm not going to be adding the 92 plus module to this, but these aren't necessary because it's already got the ROM. So I pulled one off of here and transplanted it here. And well, this unit still doesn't work. So you can see one of the bodge wires already in there. There's some more tracing I need to do to get this one running, but It does have a good screen because on occasion it'll start up and it's all black, so there are no lines and everything. So eventually I'll figure out what's wrong with that one. But this is a very clean model. So there we have it. We have the replacement connector on there, and put this cover back on, and we should be good to go. So we can use the GraphLink software, and usually what I do is I'll use the software to grab a screenshot. It has a feature to grab a screenshot and test it that way, and then do a backup, and that'll test the connection here. Or you can connect this to another TI-92 and try to transfer a program, or enter the chat program that's in the user manual and see if you can make a connection to the other unit. So anyhow, this one is repaired. It was pretty simple to do that, and these are again a couple of bucks each for these. You know, I just happen to have them on hand, but I will link the part number to these in the description. Both the Mauser part number and the manufacturer part number, in case you wanted to get it somewhere else. That is it for now.